Hi everyone, and welcome to today's webinar, Compliance Using MBSE. My name is Katie, Communications Manager at Vitech, and I will be your host during today's webinar presented by Warren Smith. For many years, it has been thought that highly regulated environments would benefit from using CORE, but it wasn't until recently that Warren was able to build us a demonstration to show exactly how a team could achieve the confidence of CORE to ensure compliance. CORE has long served a multitude of industries to help teams manage their complex project systems. Today we are seeing rapid expansion into new industries as the value of systems engineering, and particularly model-based systems engineering, is realized. Our lead presenter today is Warren Smith. He's a senior executive here at Vitech and a senior systems engineer. He has over 25 years experience working on all aspects of systems engineering and project management, and has worked extensively in both mil-aero and commercial industries. He has deep knowledge of systems engineering and model-based systems engineering tools. Warren is often found presenting at local and cozy chapter meetings as well as national conferences. Before Warren gets started, I have just a few housekeeping items. We will be answering questions today at the end of the webinar. Please send your questions in as soon as you think of them through the question tab on the webinar control panel. Warren will answer as many questions as he can today, but if we do not get to your question, we will reach out to you after the webinar. The webinar is being recorded today, so if you experience connection problems during the live presentation, a recording will be available by request within 24 hours of the live version. We will also post the webinar to Vitech's webinar archive located on our website. I will send out the link in the chat window now. Now I'm going to turn the presentation over to Warren. Welcome.
Hi, Katie. Thank you so much for that introduction. Let's see. I will make myself a presenter, and we'll get started. Okay. Can you see my screen okay, Katie? I think so. Okay, I'm gonna proceed. As Katie said, we're going to be discussing compliance, demonstrating compliance using model-based systems engineering with CORE. I'm going to go through about 15 minutes or so of presentation material to orient anyone that's new to Vitech and CORE and model-based systems engineering to what this is all about, and then we'll move into a demonstration demonstrating compliance using CORE. CORE is a multifaceted tool. It allows systems engineers to manage all of the systems engineering types of artifacts that we need to handle in our day-to-day work. It allows us to create and manage design data in a number of different formats. Textually, tabularly, it allows us to annotate or attribute information to our designs. It allows us to create architecture and behavioral models using a diagramming technique. It's actually a view technique, which is a little subtle. We'll talk about that more later. But it also lets you do simulation of your systems. So in addition to being able to manage both textual type of information, graphical type of information, do simulation and so forth, it lets you capture all of the different types of information that you need to capture as a systems engineer. Now, one of the things that's really nice about CORE is that it has the ability to output various types of systems engineering deliverables. It can provide things like traceability matrices. It can provide specifications, design documents, and test plans and procedures straight out of the model with no post-processing required. We call this auto-document generation. These types of outputs really make CORE and GENESYS not just a tool for model-based systems engineering, but really an integrated platform that the team can use to increase engineering productivity and reduce development time and cost. Finally, all of the information that's captured inside of CORE is interrelated, and that's very important because the fact that all of these different types of data are related means that CORE can produce support to the engineering design team that it couldn't do otherwise. Now, CORE is a model-centric tool. It is not a diagram-centric or a document-centric tool. If you look at CORE as an integrated platform, what you'll see is a single integrated repository that captures all of these types of information that I just described on the last slide. And that information is populated into the model through various source material, and there's outputs that are generated as well. But the thing that's critical is that the entire design team can use CORE to do whatever kind of work they want to use or do. So for instance, over here on the left, we have someone that's doing some behavior modeling. They're looking at a very complex system, and they're trying to figure out how all the moving parts are supposed to work together, so to speak, in order for the system to perform the functions that it's supposed to perform to satisfy the stakeholders and users' needs. This is a graphical type of process, and she's working graphically. If I look over here, this gentleman is actually doing some simulation, perhaps of the models that she is producing over here to his left. Excuse me. And this simulation is being done, again, out of information from the same repository as the behavior modeling is occurring. The third woman here is doing perhaps some requirements work, some textual work, working on a list of regulations or requirements that are necessary to be met, that have to be met for the system to be fully functional and compliant. And then finally over here we have a gentleman doing some architecture work. And in fact he has a highly stylized version of his architecture diagram. Each of these elements, even though they have graphics associated with them, are semantic elements in the model. But what this means is that he's able to present that information at design reviews. So how does the common model work? Well, essentially what will happen is that any one person might make a change to some element in the model, or in this case to two different elements. And because it's a common model and not a series of disjointed tools like PowerPoint or Word or any other tool or capability, that means that those changes as they are made are instantly available and propagated to the rest of the design team. So you don't have any stale data. Of course, every one of these elements is baseline. The system model and design can be baseline. There's a full audit trail of who made changes and what the changes were and when they were made. So you can see all of that. But what this means is that there's no guessing when you have a large distributed design team as to what the system design looks like. Requirements, architecture, tests, compliance reports, all of that is up to date all the time. And so we have one version of the truth when it comes to the system design. Now, CORE has been originally designed for systems engineers by systems engineers, and so we satisfy all of the needs that systems engineers have. Now, there's a number of ancillary artifacts and work products that systems engineers produce. One of them is compliance, which we'll get to soon. But these four domains are the primary domains that systems engineers need to work within, and CORE satisfies them all. So in the upper left-hand corner, we see source requirements. Yes, it's true that systems engineers are responsible for developing system, subsystem, and lower-level requirements. They're responsible for doing operational analysis. They're responsible for writing down and eliciting customer requirements and for making sure that those requirements can, in fact, be satisfied by the system design. In the upper right-hand corner, we have the behavior domain. This is actually a list of the things the system must do in order to satisfy those requirements. So if a customer has some overall needs and something that the system must do, is required to do, well, the behavior domain is where the analysis actually comes in, the engineering analysis, to determine exactly how the system will do that. And each one of those functional behaviors or the states the system would be in are actually then allocated to a series of components that will perform those steps. Those components, whether they're hardware, software, process, or anything else, are captured in the architectural domain. And of course, everything needs to always be verified and validated. We want to make sure that our system is validated to make sure that it satisfies the customer needs. Every one of these components has to be tested and verified that it does what we want it to do. So there's a lot of traceability that's going on in a systems design. And so we capture that inside of core as a series of relationships. And these relationships are very important because the presence or absence of relationships between these different domains means that the engineer is able to ascertain the relative completeness of the system design. Some of the other webinars that we've done have shown how managers, for instance, can get real-time project metrics and status based upon the completion of these different 4 domains and the relationships between them. Today we're going to take a slightly different look at this. We're going to look at compliance. Now, when you look at core, and I'll be opening it up in a few minutes here, you're going to see a system that has an Explorer view over here, identifying a set of categories, classes, folders that map to those domains that we just talked about. So if you look inside any one of these, this one has an assembly thread folder open, you'll see a list of elements inside of your system design that reside inside that folder. And again, selecting on any one of those will get you, allow you access to the inner workings and hidden mechanisms of, in this case, that assembly step. Now I'm showing this to you because this is what the core client looks like, but it maps perfectly to those 4 domains. The architecture is captured in the component category or class. The behavior is captured in the functions and state classes. Obviously we have a requirements folder and we have a number of classes that capture all the richness of the verification and validation effort. So if systems engineers are responsible for the 4 primary domains, well then core is the tool, the model-based systems engineering tool that allows them to work comprehensively, holistically in all these domains together. Now let's move on to compliance. Core adds to those 4 domains. It adds to it in a variety of different ways. You can look at test activities and verification test procedures, and you can do all of your test planning. That's one of the additions that Core adds to those 4 domains. Why is that? Because as systems engineers, we're responsible for both ends of the V model. We also perform a lot of modeling in the project management and workflow area, and I'm about to show you that in just a moment. There are 2 types of compliance. There's design compliance and there's process compliance. Design compliance is designed or enables that one can show and demonstrate that the design is properly sourced from a set of regulations or system requirements and provides the ability to demonstrate that all stakeholder needs are being met. Those stakeholders may be users of a system. They may be government agencies requiring certain regulatory compliance. Examples of this might be medical device design control for ensuring that one can trace a defect all the way back up through the chain of design artifacts, from the failure through the design and the architecture into the requirements. It may be a Department of Defense compliance required to show that you have completely satisfied all system requirements in order to successfully deliver the system to your customer. That's design compliance. Process compliance is a little bit different. Process compliance is the ability to demonstrate that your development process, that the way you do your development adheres to some documented process. ISO is an example of this, as is CMMI. What the purpose of a process compliant activity is to show that you actually do go through the series of steps that you say you will go through in order to generate the product that you produce. And sometimes the process is prescriptive. Sometimes the process, the design process, the development process is given to you, and you're told to use a particular development process, like IEEE 12207 or something like that. Sometimes the process is one that you control. In ISO certifications, typically the organization develops their own process, documents that process, but then has to demonstrate compliance to their own process in order to get or retain their various ISO certifications. So let's talk about each one of these two. First, we're going to talk about design compliance. Both Core and GENESYS perform these types of features that we'll be talking about over the next 45 minutes. Design compliance. Duplicate. Design compliance. Okay, so earlier I showed this this diagram at the top here and showed how the various types of artifacts that systems engineers are responsible for are interrelated with relationships. Using our tools, you're able to go through a series of export steps to export traceability that follows various threads through this complex web of relationships up above. Because Core and GENESYS, they keep track, they do the technical bookkeeping of all of this complexity in your design and allows you to output the relationships mapped in the way that you want. That means that you get an output that can look something like this. Here we have a couple of regulations that come from a variety of sources, and we see that there are relationships like these that relate these regulations to a series of requirements. And in fact, this one is mapped to one requirement, this is mapped to one requirement, which has additional flow through the system. So here we have requirements that satisfy the regulation. But that requirement then, these requirements are actually the basis of behavior in the system, functional state behavior in the system, which is then allocated to various sets of components. Finally, we can see through this design compliance matrix that each one of these requirements, the text isn't shown here, these are the names, each one of these requirements is verified by some information. Now the red here shows that there are some gaps. So wherever you see an empty field, you have a gap in your design compliance matrix. And in fact, what this is pointing to is missing relationships or missing design artifacts. this type of design compliance, this type of traceability report, is used to ensure that your design covers all of the requirements and regulations that are necessary. And as you can see, it's very easy by looking at the gaps, which ones are missing. Process compliance. Today I'm going to demonstrate process compliance. I've shown you a kind of a thumbnail sketch of design compliance. I'm not going to demonstrate that today. I am going to demonstrate process compliance, which I think is a little bit more important to visualize out of the tool. Now, Core and GENESYS actually have built-in project management classes of information, and you can group them together and look at them as this chart shows. Essentially, you're going to see a number of key types of categories of information that are used to model your project workflow. The project workflow, since it's in that integrated environment that I showed you at the beginning of these slides, it will allow you to relate to the design. So the first piece that I'm going to talk about is going to be the organizational structure. You can actually have build org charts inside of Core and GENESYS. You can import them from other sources if you want to, but you can build them up. It allows you to show when there are changes to your system design on a complex, a joint venture or some sort of complex organization, what the impact of those design changes will be on the organizational structures. You can also capture work breakdown structures. You can capture the actual work packages with the various costs in terms of hours or dollars, recurring, non-recurring, and so forth, that are allocated to the organizations that need to perform those work packages and implement that work during the project design. You can actually import and export this information with your costing system, whatever that may be, using a very straightforward import-export capability. You can also model project execution. So you can actually put together a workflow that shows the process activities that each of those work breakdown structures are funding, each of those elements are funding, in order to accomplish your system design. In fact, one of the things that's really cool about the tools are that you can actually simulate your project using these activities and say, gosh, we're going to be doing some analysis and some design activities. We're going to be doing some testing activities. Let's put some durations on there and see how long we think this project will take. But this program activity model is the basis of Core's ability to model your workflow for compliance. And of course, all of these are linked together. So if I look at this from the bottom up, here's the organization, here's a work breakdown element that this organization is responsible for that provides costing, and here is an activity, a program activity that has to be performed with the money in this mission analysis WBS. Now today I wanted to show you this to give you an introduction to the various program management features that we have. Today we're going to switch over the demo and look primarily at the program activities and how that works with compliance. Just one moment while I switch over. Okay. Over here you can see I've opened up Core, and over here you can see some of these program activities. We have some requirements and so forth. inside of our model. We've integrated these program activities, as I mentioned, with the architecture and the behavior and the tests and so forth. So let's look at a process flow and a process diagram. Okay, I'll just shrink these out of the way here. So here we have a model that's created inside of Core for some sort of nuclear agency. And it's actually being built, the system, by the Acme Corporation, which is a corporation that makes everything. And it shows the various planning phases of the system design process. We have a planning phase and a system requirements analysis phase during the initiation. The engineering has various preliminary designs and detailed designs, and we're going to be doing some testing. We're going to have some maintenance during installation and commissioning. And between the initiation of the project and the engineering phase, we're going to have a system requirements review. After the preliminary design, we're going to have a preliminary design review and a critical design review. We're going to have a factory acceptance test and the site acceptance test down here as well. So it's very easy to model your system. You can drag and drop additional elements on this if you want to do that, and and simply change around your process. So if I wanted to add something down here, I can just simply add a new node on and put in the new name, and I'm off to the races. But let's look at the details of one of these blocks. Let's look at the details of the system requirements analysis. I'm going to open this up, and I'm going to read the description of what we're going to do during this systems analysis phase. So you can see there's a lot of text associated with this that describes the purpose of the systems requirements analysis phase and what the specification has to do and so forth. In fact, we find when we look at this that this process to analyze the requirements is actually being done in accordance with a process spec. And it's the IEEE 12207 spec. And I've got it hyperlinked here in Core. So I'm going to go ahead and open this, and it will bring me open to a PDF version of this IEEE 12207. So here I can see that the system requirements analysis process is well documented in this IEEE spec. So since I'm doing some regulatorily significant work, if that's a word, I'm going to make sure that I develop my system following this process. And I'm going to do that to make sure that I get these outcomes here. I want to make sure that the problem is solved. I need to make sure, and this one's kind of important, that the system requirements have been analyzed for correctness and testability. Okay, well, I'm going to have a way of doing that in my system development process. I'm going to have people and organizations that are responsible for that, and so we'll come back to that later. But I can scroll through and see what this process looks like. So, by taking this this particular development process, I'm going to actually model all of those steps and look at those series of sequence steps that are documented in that process inside of this step. So I'm going to open this up and look at a more detailed look of what's inside this block. What's inside this block is all of this. So I can see that I have my requirements analysis process. It starts from the planning phase, right? And then I do all this stuff in that one block that I showed you before I can get to the preliminary design phase over there on the right. And so this is going to be a pretty significant effort. So let's look at what it means to have Core or GENESYS manage our workflow, right? And to demonstrate compliance to that workflow. So we're going to look at this first step here. I'm going to open it up. And I can see that the team is required to coordinate with the customer to obtain specific requirements. And it gives me the list of the different kinds of things I need to talk to the customer about. I have to include functions and system capabilities and organizational requirements and safety and all of these kinds of things. But one of the things that's nice is that inside of this step, this procedural step, I have a description of the compliance method. If I am going through a process audit and I have a process auditor come in and say, okay, show me your process and show me your workflow. Well, gosh, I can come in here, I can show them this process, I can open up each step, and I can show him what we do inside of each step. And furthermore, I can let him or her actually generate a report themselves from the tool to see if we actually satisfy or are compliant with the this step. Now notice here that the way we look at it is this workflow is a description of what we do, but we recognize that people do work, they do work as information becomes available. What that means is that these tools do not prescriptively restrict the order or the stages that you go through. And this is a good thing. Some workflow products will not let you move to the next step until there's been some validation that this has been complete. Well, the issue with that is that if you're part way complete with this step, it would be nice if you have resources available to move on in those particular areas and do the next step even while others are completing the previous step. So the fact that we capture it, that we capture the workflow, that we generate compliance, process compliance, but we're not prescriptive, gives you more flexibility to get your work done more efficiently. Let's look at another one. Here's the one that maps to that item C that I showed you in the process document. This is the one that validates correctness and testability. Okay? And so we have a compliance method here. It's to export a report called the compliance report, requirements, correct and testable report. So I'll go do that in a minute. But let's take a look at what it means to actually validate that every requirement is in fact correct and testable. What does that mean? I'll minimize that. Let's come on over to our requirements. We know that our customer requirements have to be correct and testable. Well, I've moved over here to the requirements folder, and I'm actually looking at these customer requirements, and here they are. So, you know, I can look at some of these requirements. Some of them have text associated with them. Some of them are structure rather, and some of them are requirements. But here you can see that we actually have requirements. We've put them in blue. Core supports a variety of text colors, fonts, and so forth to make them stand out. And we can see the rationale. We can see what type of requirement it is. In fact, we do full requirements management, obviously. But you can see here we have the sign-off. The quality sign-off is responsible for the correctness, and the test sign-off is responsible for the completeness. So I'll switch to another one here, security requirements. System shall be secure from open internet access. So these requirements are going to be validated themselves. They'll also be related, as I showed you in the PowerPoint part of the presentation, to the design, the architecture, and the behavior. And each one of these will be tested. But right now we're just checking for compliance. So let's take a look at how we would do that. Well, we have added, this is not out of the box, it's one of the easy customizations that you can make on your own. We've added these two sign-off attributes, one for quality and one for test. So when the quality engineer has validated that this requirement is in fact correct, then he or she is going to log on and select his name, in this case, W. Edward Deming, to sign off on this particular requirement. Now, Core is going to do a couple of interesting things. One is it's going to provide you with a history showing that this requirement was actually, initially it was empty, nil, but it was then changed by the person logged in as Deming. I'm playing Mr. Deming today, and he actually went in and signed off on this requirement. Now, if some imposter logged in using someone else's, using their own login, then this history would show that this value was not changed by Edward, that it was changed by someone else. So this is one of the many features that we have that allows you to very easily and with a light touch control how you perform your compliance steps. Now we also have heavier hands if you would like. I know some of you are thinking that's good, but you don't want just anyone to be able to change that or futz around with it after the fact and so forth. The history is helpful, but that's not good enough for you. Well, let's take a look at the test engineer. This requirement has to be testable. I really don't think this is testable, but we'll just pretend for this time being that it is. So we're going to have the test engineer log in, and I won't go through that process now, but the test engineer could log in, and when he was doing his review of these, or she, then when he went through and he set this to signature authority essentially to himself, you'll see that Core has locked this. This can no longer be changed. I cannot change this ever again. You have to have very special administrative type access in order to affect this change. So this is a more direct way of ensuring that once these steps have occurred, that you can't go back without going through a real formal process. So we have Deming and Yeager have gone through, and maybe I'll set a couple more of these. Let's say Deming's deputy did this one, and so forth. I'll just hit a couple of these. What about that compliance? Well, as you recall, I actually have this process step here, and it tells me how I can have an independent auditor go into the tool. I'm not spending weeks and months generating reports and spending a ton of money before the audit. I'm just doing my work. I'm running through my process. I'm doing my workflow. But I can have the auditor come in and actually independently demonstrate compliance by running this correctness and testable report. So now that I know that, let's go ahead and do that and see what it looks like. So it says that I should export a Word document, and I'm going to do it on the requirements class. And I'm going to, I have a number of reports here. Flow down, trace. I would use some of these for the design compliance that I mentioned earlier. But today we're doing process compliance. I'm going to select this particular report format. Excuse me. So I'm going to go ahead and click through this. I have some options here on how the report should look like. I'm going to have it in landscape. And I will overwrite my last one. And voila. Here I have a report demonstrating that I am complying with my 12207 process step of item C that showed that the system requirements have been analyzed for correctness and testability. And what this compliance report shows is that I'm not very compliant yet. I have a lot of these that I still have to work on, but I am getting there. And you can see that our team here is working through these. We can also see that the test engineer is probably only going to validate that the requirements are compliant if there's an actual test procedure associated with it. So I think that we'll save that for another day. But as I've shown you already, every requirement, of course, needs to have a test associated with it, or at least assessed in some way. So that would be an important part of this compliance report. So hopefully what you've learned today is that Core and GENESYS MBSE tools can be used for both design compliance, showing that the system as built does in fact satisfy all regulatory and system requirements, but also that we support design process compliance. And you can be certain that every step in a process workflow in a flexible, non-prescriptive way can be validated at a very low cost and very easily using the MBSE core tools. Katie, do we have any questions?
We do. So we've got a few questions, and if you have any questions you haven't had a chance to enter yet, go ahead and put them into the questions tab in your webinar control panel. The first one I've got is from Ben. He asks, what processes can be used for process compliance?
That's a great question, Ben. The thing that's really nice about these MBSE tools is that it can be any process. We don't restrict you from using any process that you might want. In fact, that 12207 process was one that I put together just from simply reading that spec. If our organization was tied to that, we could make that a reusable element, and we could reuse that process over and over and over again on every single MBSE project that we perform between now and the time that that we wanted to update or change that process. So yes, anything you can do, either a standard process like this one, or an internally developed process, which most of the companies I've worked with have used actually internally developed processes. This provides an excellent way of capturing all that and linking it to your actual design work.
Okay, thank you. I've got another one from Eric. He wants to know, can compliance reports be generated automatically?
Yes, they can. As a matter of fact, we have. I'll switch back here to the tool. This report that I actually generated and showed you, I closed it, but you can actually auto-generate reports using what's called a task scheduler. So it would take a little bit, not much, a little bit of support from our professional services group to get you set up, but you can set up a new task to generate a report on a regular basis, and you would put in a description, identify the project, and so forth. And what's really neat is that you can actually decide when you want to do it. So, like for instance, if you want to generate a report every Friday that's midnight or 1 a.m., that kind of thing, you can actually set it up. It goes onto this task list, and these reports can be automatically generated. They can be saved to the file system. Our PS group put together a great demo for me to email, take a compliance report and email it to a manager on a regular basis. So you can easily, managers can easily track the progress that the team is making in complying to either their design or their process compliance. Good question.
Okay, great. We've got one. Oh, we've got one from Paul. Paul wants to know if CORE produces a design compliance matrix as you showed in the presentation.
Yes, that was generated from CORE. I actually I added a this one here. In this particular chart, I added some regulatory requirements and the traceability, and then I used our wizard to generate this. The only thing that CORE didn't do was make these red. I did that to highlight the gaps. These come out empty, which is which is obvious in and of itself, but just for presentation, I made those cells red myself. But yeah, this was actually generated in Word directly from CORE. It was super easy.
Okay, I think this question is on a similar line. It's from Daniel. He's saying on slides 15 and 16, how did you create the table in CORE? Was it with the export tool or with a script?
Yeah. So since it's of keen interest, essentially what I did is I used. In fact, I don't have a project open that will give me a good output, but I'll show it to you. You can use this yourself if you have CORE. If you're interested in getting it, obviously contact us and we'll work with you. But using this wizard, I selected the requirement, and then I came over here, and there's a requirements flow down. The requirements flow down view, and I use this as the basis. I added a little bit to it, but this basically will output. Each one of these positions represents a column in the table, so it outputs the requirement number and the requirement name and the text, and then it will output any subordinate requirements that refine that, and then it will output the functions that are are based on that requirement, and it will output the components and actually even the tests as well in the one that I put out. So yeah, we have these set of predefined canned reports down here. Some of these, like this compliance report, I generated as part of this compliance demonstration, and I was able to just simply take my new report and give it a name, and it becomes part of my repertoire for whatever work I'm doing. So that's how I did it.
Okay, great. Also from Daniel, he was interested on how you enter a hyperlink in an element's definition attribute.
It's really nice. You select it, and you right mouse click, and you insert a hyperlink. And you put in the path or the URL. One of the things that's really cool about this feature is that these hyperlinks are exported with the HTML team view output. So when you generate the web, static web version of this, it's navigable. These hyperlinks are navigable as well. So you can actually use this to link in, like I did, your own internal documents or other websites or whatever you want. It's a terrific feature, and I think too often underused by the user community.
All right, thank you. Nancy would like for you to show an example of a quality sign-off.
Okay. Well, right here, this particular requirement has been. Well, let me back up, Nancy. There are different ways of doing sign-offs. I chose a way that, for this demonstration, that that demonstrates the capability. If this particular way satisfies your needs, it's a very simple and easy way of doing it. If it doesn't, we have other features in the tool that can be used to sign off capabilities and so forth. And I'll show you one in a minute. But here, these blocks here are literally sign-off blocks in this approach. So I am logged in as Mr. Deming. So when I make a change, that change is recorded in the audit trail that I made it. So here, I literally am going to select my name, saying essentially an electronic sign-off. And the history then shows that it was empty, it was nil, but on this date at this time, I'm not in the West Coast time zone, that it was signed off by this person. So you can easily see that my login, I was logged in, and then I signed it off. There are other options. You can actually allow, for instance, Mr. Deming, when he thinks that this is correct and complete, to lock it and prevent any other changes from occurring. That's not true for the other requirements around it, just this one. But this is an example of what I mean by there being a set of features that can support your vision of what an electronic sign-off would entail.
Okay, thank you. This is our last question. It's from Jason. He says on slide 16, you show a design compliance gaps where a regulation is satisfied by a requirement. What relationship was used for this to differentiate it from other requirements?
Okay, that's a good question too. A lot of detailed questions. Okay, so this is not the model that I did it in. So let me replicate it quickly. What I did for that is I created a new folder called Regulatory Requirements here, and I created these requirements. We'll say authority to use regulation. And I captured the requirement, the regulation text here. And then I literally create a standard refines relationship to other requirements. So what I did is I linked this requirement to other requirements. We'll just take one of these. But when I did my report, Jason, what I did was when I output my regulatory report, I exported it to Word, and instead of starting here on the requirements folder, I started here. And then I went and I did a modification of this flow down, and I outputted a report that had the regulation. You have to change the headings yourself. Let me redo that. In the interests of completely answering Jason's question, I'm going to redo it. So the first thing here will be the regulation. And you save these, right? So that you can reuse them. So we have the regulation, we have the requirement that refines, and so on and so forth. And then these other ones would be filled in with functions, components, and so on and so forth. So I hope that answers your question, Jason. If it does, go ahead and just in the chat tell Katie if that satisfied that question or not.
All right, I'll keep an eye out for that. And so that wraps up our question and answer time for today. And if you have any other questions or comments for Warren, if you get into the tool and you start poking around and you need a reminder on something, please don't hesitate to shoot Warren or our support team an email. Warren's address will hopefully be on the screen in a moment. If you can pull that up for us.
Yeah, I'll put it up there. Hold on just a second.
Okay. In addition, you can post your questions and comments in the forum of our community site or on Vitech Corporation's LinkedIn group page. I will chat out the link to the community page right now. And thank you so much to everyone for coming today and for your great questions. We are excited about the new use of CORE and the traction that it is gaining in the industry. We do have one more note for today. At the conclusion of this webinar, a survey is going to open on your screen. Please take a moment to give us feedback on today's presentation. We do read your feedback and use it as we're planning future presentations. And you can also let us know what kind of topics you'd like to see on future webinars. And that is all for today. And Warren, Jason did write back and say thank you, so I think he is in good shape. So thank you, everybody, and thank you for joining us, and have a wonderful day.